This lesson is the Introduction to Time Series Data Part 1, focused on the importance of the metadata. In this lesson, you will be introduced to a few of the many types of time series data, mostly visualized with time plots here. You will hear terms that are used in the time series jargon, such as time plot, multiple time plot, metadata, moving average, trend, seasonally adjusted, seasonality, and a spaghetti time plot. Why is it important to know all that? Time series that we obtain from different sources do not always come in raw form. That means they are not given to us as the raw measurements, the direct measurements, but rather it's given to us after something has been done to the data. Some transformations have been done to the data. In order to conduct a correct time series analysis, we need to understand first what has been done to the time series before we start analyzing it. We need to know what is called the metadata, the data about the data. What is a time series? A time series is the repeated measurement of the same phenomenon at different times. Here is a little example. This is a time series. There is a time index or time stamp and a measurement. In this case is the number of flu cases. Because of the temporal nature, we must take into account the correlation between the successive observations between the flu cases in this case. What is a time series good for? Look at this time series again. The time series helps you understand the past, the data that has been observed already, and use this data in the understanding to predict the future. The presence of correlation, however, makes the analysis of time series data and the interpretation of the results from that analysis much more difficult than in the independent data case. What shouldn't we do to a time series? Never sort the time series by the variable name. Here is data A, has the year in order, lowest year, highest year. If we sorted data A by flu cases from lowest to highest, you get a data set, data B, that is not a time series. Notice how in this data now, because we sorted flu cases from lowest to highest, we end up with the year 1996 before 1991. Obviously, data B is not giving us the same information as data A. Let's look at some examples. Time series, for example, during the COVID pandemic. This is a plot that has actually 11 time series displayed in it. Each time series represents the 7-day moving average or the average of the 7 days confirmed cases. And each of them is a time plot. We say that because time is on the horizontal axis, the value of the variable is on the vertical axis, and the observations are connected by lines. We call this a multiple time series plot. Here is a question for you. Why do you think they average the observations of 7 days and give you each day the average of the 7 days? Everyone was exposed to time series data during the COVID pandemic. In fact, during the COVID pandemic, a lot of people became literate in time series without them knowing that. There are numerous sources of time series data. Here are some examples: Google Trends, Fred, the M forecasting competitions, web APIs, for example, Quandl, time series data repositories, data sets in R packages, sensor data from smart cities, medical devices, signals for radio, music, medical devices, and then many countries, organizations also collect and make data available. Here is another example, Google Trends. In this image, you can see the interest in basketball in the last 5 years in 4 different states of the United States. There are 4 weekly time series displayed. This is an image with 4 time plots, one for each state. And in this plot, we can access the metadata. We can click on the question mark and find out what it is that is being measured. Here are some questions that the time plot helps you answer. Which state has the most interest in basketball during the time analyzed? What is common to the interest in basketball in all 3 states during this time? What do you predict will happen to interest in baseball? Actually, you should say basketball in those states after December 2021. What could those periodic peaks represent? Here is another example, Fred data. In this image, you can see the monthly supply of houses in the United States. There is 1 monthly seasonally adjusted time series displayed. It's an image with 1 time plot. Some metadata is displayed on the page. Question for you, can you repeat what the metadata is saying? Another question, what do you think seasonally adjusted means? One more example. Continuous glucose monitor sensor data from a diabetic individual. This is from one presentation I gave to the joint statistical meetings in 2021. There are many time series of several days at different half hours of the day. It's what is called a spaghetti plot. In reality, this is just 1 time series, but we have split it into different time series, 1 for each day, in order to see what's happening each day and comparing the days. It's called a spaghetti plot because it's just 1 time series converted to many time series. And those are parts of the bigger time series. A spaghetti plot is a plot of 1 time series split into several parts with the parts superimposed. So according to this graph, what happens during the day? How well is this person managing diabetes? One more example. This is sensor parking occupancy in percentage between 8 a.m. and 5 p.m. at 2 different parking structures. These are 2 time series, 1 for each parking structure. The occupancy exhibits daily and weekly seasonality. Can you see it? But not every hour of the day has an observation. So this is a data set that could pose some problems later on. Question for you, describe the weekly seasonality. Guess the features of the daily seasonality. Time series differ from the independent and identically distributed observations case that you may be used to. Here is an example of an IID case. This is a data set that contains the variable heaters, the number of effective heaters per building observed in different buildings that were randomly chosen in a given Thursday. IID are measurements observed by random sampling from some population. Because the sampling is random, the observations are not correlated. You may sort the data by the heaters variable and the data still says the same as before sorting. As you can see here, we don't have a time index. We have just an ID for the building. What we notice in this lesson is the following. There is a large variety of time series data, and some data is given to us already transformed somehow. All the plots in here are time plots, which is the way the time series should be visualized to spot trends and seasonality. Some plots show one time series, others show more than one series, and some are spaghetti time series plots. The data displayed in plots represent different stages of data processing. Some time plots are showing moving averages, other time plots are showing seasonally adjusted data, others show raw, perhaps aggregated data. That is why it is very important to know the metadata. Some time plots show trends, and other time plots show just seasonality. There can be more than one seasonality. All of this is very important to take into account before you start analyzing a time series. You need the metadata. I hope you enjoyed this presentation. Thank you for listening.